right. Thank you, Sue, and to AIA Potomac Valley for hosting us today. Thank you again I also thank you to Grimm Parker for organizing today's lunch and learn. Hopefully folks brought their lunch with them. I'll bring the learning part of this. My name is Aaron Fisher. I am the Vice President of Business Development here at Ernest Maier. Today's talk will be on permeable articulating concrete blocks for stormwater management. So this is a tool that should be in your toolbox as you look to address stormwater challenges as part of your site plans, as part of your stormwater management plans. If you're not looking and thinking about permeable articulating concrete blocks, you should be. I'd like to start though quickly with who is Ernest Maier. As our tagline aptly suggests, we are more than just blocks. So if you know us as a masonry supply house, we certainly do that and do that well, but that is not the only thing we do. And that is not the only place. Bladensburg, we've expanded well beyond our Bladensburg headquarters, all up and down the mid-Atlantic. So out to Charlottesville and out to the beaches, operating under a few different names. We do everything now from ready mix concrete to precast concrete, to brick masonry, to hardscaping, to one of our latest products we just picked up is fiberglass rebar, which is actually, we might think that might be a little bit more expensive, but it's actually cheaper right now than steel rebar. It's actually a superior product at a lower cost. And so if you're concerned about corrosion or any of the things that went down Seaside Heights last year, unfortunately in Florida, corrosion was the problem. A rebar that does not corrode would certainly be one way to solve a problem like that. So any of those products, anything that interests you, please feel free to reach out. We're always introducing new products, not just because they're interesting or exciting, but because they're better, they're more sustainable. And that's how we got into permeable articulating concrete blocks, which we sell under the name Pave Drain. Just the housekeeping slides. A certificate of attendance will be provided by AIA Potomac Valley. If you have review questions, I have the chat open. You feel free to chat them in. I will do my best to work them in. If not, I will have a Q&A at the end of the session. This course not only gives credit, an HSW credit, it gives a LEED credit and a LACES credit. If you are a landscape architect and would like that credit as well, please do send along your contact information as well as your ID number so I can make sure to report that information to LACES. There is a quiz you also need to take too if you are interested in the LACES credit. It's a 10-question quiz. Hopefully it's not a big stumper for you here. I also like to talk about the learning objectives. So this is the last introductory slide. So what should you walk away with? Understanding that P-ACBs, so permeable articulating concrete blocks, are an option when designing permeable pavement, but also an option when you're thinking about addressing your stormwater challenges. So first I start out by comparing and contrasting what an articulating concrete block is to an interlocking concrete paver, which is probably the product you're most familiar with and thinking about. How best to install this, what you should expect in terms of performance, and then maintenance. This is really the big one. So we save it nice to the end. So hopefully you stick around to hear that piece. So starting off with the basics, what is an articulating concrete block? It is a matrix of interconnected concrete block units. They interlock in one of three ways, either based upon the geometry, so the shape of the block, cables, so that's a system that runs through the blocks, or geofabric, so something that kind of sits on them. So think like a Lego board, you can kind of plug them in. The key thing is they form a hard yet pervious surface via open joints. So that open joint is really the key thing here. That joint is how the water gets from the surface to the soil and ultimately back into the water cycle. And you're thinking, yeah, that sounds a lot like a paver. Well, it's similar, but it's not quite the same. So you can see on the left, there's an articulating concrete block. And on the right, you can see your traditional paver. So there's a difference in thickness. An articulating concrete block is about 5.5 inches thick. A paver is between 2.5 to 3.25 inch thick. And so there's a little bit of difference there. But they're similar. They're not far off. They're both made from concrete. So anything that any color you can make concrete, you can make a paver, you can make an ACB. They both form that hard yet permeable surface to prevent erosion. I will stress that when the systems fail, it is generally not exactly the surface that's causing the problem. It's the things below the surface. So compaction, geofabrics that are all really critical. to making sure that the system performs like you're expecting. And then finally, that stone base, that's really the stormwater structure. So the gravel underneath, the stone underneath is actually what holds the water and allows it to infiltrate into the soil. So that allows you to disconnect from the stormwater system and allows the stormwater to actually go back into the natural water cycle where it would in a distributed fashion. But why are they different? So the answer to 2 different ASTM standards. So if you do specify an ASTM standard, you do scope out ACB systems. So please be sure to not to give it kind of an or equal. The joints, this is really the big one. ACB systems have open joints. So there is no material in the joints. There's no sand, there's no stone, there's no crushed rock, nothing in the joints. Whereas pavers require material in the joints. This is really big because this kind of changes how much water they take on, but also changes how maintenance is performed, how they clogged. All of those kind of things change pretty dramatically when you have the joints, as we like affectionately call them. They fill them, but that we affectionately call that pre-clog. So that really starts the clogging process. Additionally, the ACB systems are interlocked. They're always interlocked. That is how those systems are set up. Pavers are sometimes interlocked, and that's when you have a herringbone pattern that generates that interlocking pattern and is generally recommended when you have traffic applications. So when you have cars driving on them, you do need that additional strength from that end. So what is the difference is open joints may not seem like a really revolutionary idea. We really think it's not, but it generates a lot of different performance characteristics. The blocks tend to be stronger because they're much bigger. Because there's a little bit more material, there's a little bit of a higher price point to them, but you certainly gain in the long run in terms of maintenance very quickly. Performance, these systems perform much higher initially and then perform much better over the whole life of the project, even in the absence of maintenance. When you do have to perform maintenance, it is much simpler, it is much easier, and generally results in restoring significant performance back to these systems that greatly exceeds what you would get from a interlocking concrete paver system. And ultimately the use case. ACB systems can be used under heavy traffic loading. You can put them in a drive aisle, you can put trucks on them, you can put cranes on them. We have a whole bunch of pictures for this and we'll stress that and talk through that. So I like to start with a little bit of design flexibility. So ACBs really began life as an erosion control system or a vetment system. So there's a lot of really different options out there. Not all of these can be pavement systems, but these are all ACB systems. I will also note the interlocking adds strength. So the joints between the P-ACB systems are always meant to be left open, no sweeping of rocks, no sand, nothing in them. And really this increases the strength across the system, which results in a really great performance when you're thinking about traffic loading. Traditional interlocking concrete pavers are not recommended for anything over very light duty kind of parking applications, whereas a P-ACB system can be used for heavy duty traffic. So things like a trash truck, fire engines, all those kind of use cases. It's not really hard to imagine a use case where a fire engine's driving on the system, but I don't want to be in front of a fire truck when they're there to fight a fire and go, no, you can't park here, even though it's the closest place, nearest point to your fire department connection. You got to park over there because you're going to ruin the surface. There's nobody who would ever do that. But so it's best to build a system that accommodates for how people are actually going to use their roadways, how they're actually going to use their hard surfaces, and build a system that allows for that. And here's some pictures we've done with it. So you can see semis on top of it. You can see fully loaded trucks. You can see cranes. That one actually caught us by surprise. We were not expecting to see that, but the system was no worse for the wear because it's designed to handle heavy traffic. Additionally, it can be used in roadways. So you can see on the top left, just kind of going clockwise from there. That's actually a turn aisle in the middle of the road. Next to that, to the right, you can see that they put it along the shoulder on a roadway. That's in the upper Midwest. On the right, top right corner, you can see an intersection is actually done with it. That's in PG County, Maryland. That's in Comer Manor. In the bottom left corner, you can see that's actually a bike lane. So this surface can handle bikes. And then on the right, just above that one, just closing the loop, you can see a roadway where they put it on the shoulder again to manage the runoff from the roadway. The other big thing, you can put them on slopes because they're designed, historically were designed as revetment systems. They can handle significant slopes and curves. While an option that does kind of impact how the stone bases function, because the water itself will level out underneath it. So you will need a terrace and put in some kind of like weirs underneath. But ultimately, you're able to put these in a lot of places where you wouldn't put a traditional interlocking concrete paver. Going forward, I wanted to stress we're going to talk about things that are ADA compliant. So you saw a few systems here, some ACB systems that are not ADA compliant. So they have openings that are more than ½ inch. The systems going forward that I'm going to talk about have openings less than ½ inch. In fact, in most cases, they're about ¼ inch is actually the spacer that is in the system that we regularly sell, the pave drain system. That is ¼ inch between them. So I have a little bit of question here. Do permeable ACB systems have filled or open joints? Feel free to chat that in. Happy to see that everybody, just want to see if people are listening here. Tyler's the quickest with his fingers there. Well done. Yes. Seems everyone paid attention to the one point I was stressing, that they have open joints. Yes, 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 yes. So this is really big. I will note, just to take this point, to just pause and say, you cannot take a traditional permeable interlocking concrete paver and just take the joint material out of it. If you do that, the system does not function correctly. It needs the tension, it needs the compression along the surface that the joint material does provide. And so while we would love them to kind of do that, the way traditional permeable interlocking concrete pavers are designed, they need that compression along the surface. They need that joint material to actually lock the bricks and the blocks together to hold them in place. And that's a pretty unique aspect of articulating concrete blocks and permeable articulating concrete blocks relative to other permeable pavement options. And I'll stress that articulating concrete blocks, as I mentioned, they began life as erosion control systems, and then we have kind of advanced them to the point they're pavement. So there's things that you can now drive on versus every other permeable pavement, porous asphalt, pervious concrete, permeable interlocking concrete pavers. They really began with a pavement surface and then poked holes in it to allow water to go through it. And so you kind of get back to a similar point, but because they began from different places, we're going to see that there's benefits on having begun and recognizing that water is going to go where it wants to go and starting from that point. So now that you've seen what the system is, how do you install it? Best practices. This system, an ACB is manufactured same as a CMU, a concrete masonry unit. They're dry cast into concrete molds under pressure. The units are cured on site and they're delivered. The units are cured at the plant and then delivered to site, ready to install. Now, once you've gotten your finished block, what do? We start with the installation sequence. And so as any good construction project, it begins with the plan. So planning out the system is really important. Step 2, placing and compacting the base, including those geofabrics and geotextiles. Number 3 is placing the blocks. And this is where we kind of throw people a little bit. And number 4 is actually placing and paving the adjacent asphalt or concrete. There is no need for a ribbon curb with this system. These blocks are interlocked and held in place both by their own weight and the geometry. And they can actually serve as the form or the edge for the asphalt or the concrete that's being poured next to it. This is not like any other permeable pavement system. So we note that. Looking at a cross section here, you can see beginning from what you see on the top, the P-ACB blocks on the surface. Right below that, we recommend a geogrid, a 1-inch geogrid. That's to kind of hold the rocks in place as vehicles and cars pass over. They jostle the blocks and the rocks underneath just a little bit. And if you don't put the geogrid, they tend to try to fill into the rock cavity, the arch underneath the blocks that we in our system. Right beneath them, we bed it on 57, so 3/4 inch gravel. That is different than most other systems that do bed it on sand. You can bed it on sand, but there's no reason to. You get additional volume and void space by using 57 gravel. If you need additional stormwater capacity, We recommend below the 57 using number 2 stone.
I have a question. Is there a geogrid needs to be for a certain PSF?
We have recommended geogrids, and I can kind of pass them along. I don't know if it was what kind of drove whether or not if it was a tensile strength that we needed. But I can pass you along the recommendations that we have and have not encountered any issues. Answer your question?
Yes, thank you.
Okay. And then finally, but at the interface between the stone base and the soil, we recommend an additional geogrid or geotextile. We recommend a woven monofilament. So this is something that allows water to go through, but provides structural stability. I will stress that geotextiles and geogrids really are great things to specify and not skimp on, because when the contractors do their work, good geotextiles and good geogrids can accommodate and patch over a lot of the shortcuts or failing sometimes in their construction methodologies that the contractor encounters. So I do put a slide here on geotextiles. I'm happy to talk about this more, but choosing the right geotextile is really important. Not all geotextiles are the same, even though they all have the same broad class. So things like non-woven, that's like your landscape fabrics for weed control. They don't add structural strength. If you use them and you're thinking you're providing structural strength, it doesn't do anything. You have obviously your slit tapes, so your woven ones, those are usually for erosion control. Again, that'll apply structural strength, but that won't allow water to go through. So that'll kind of defeat the purpose of using it as a stormwater BMP. There's all other types, and choosing the right type is really important, but we're welcome to, I will pass along our specs that we kind of have learned the hard way. They're hard-earned specs that we recommend. So either we're pretty confident what we recommend, or using an or equal if you're comfortable using someone else's product. After you've layered down your base and you've put it in lifts and you've compacted each of the lifts, it's now ready to place the blocks. You can either place it by hand, as you can see on the top, or you can machine lay it. I have a nice video here you can see of how the machine lay goes. Not sure if you can hear the sound, but it's just construction noise. What you can see here is 11 square feet at a time are being
That's
dropped into
place. There you go. Okay.
And then I make sure they're all lined up. And then the gentleman puts in that last block, that missing block right there. Putting them in is quite easy. And this is a really great way the machine is great if you're doing large areas. If you're doing smaller parking stalls, the hand lay is plenty efficient and a good use of money. So sequencing, again, I'm going to talk a little bit about this. So you can see the compaction, you can see the blocks are placed. And so now they are ready to go ahead and pave the adjacent asphalt right next to it. So you can see right here, they come in and pave right up against it. The blocks are built such that they're heavy enough to actually serve as the form. And so this really is a cost-saving mechanism. So you don't have to come and pour the ribbon curb and then come and place the blocks and then come and place the asphalt. You skip a whole step in the process. And that's ideal in terms of saving money and in terms of actually resulting in a superior pavement surface. So showing just a couple of different multiple installation methods, but I'll show very quickly here, there is no ribbon curb. You can place a ribbon curb. We see a lot of people are very comfortable with the way they do that, but that is not required for this system. Additionally, one of the other big benefits of the P-ACB system is when you get to curve. This is really where the contractor has to pull out their saw, cut down blocks, round them off. The P-ACB system is so good at handling water, the additional square footage isn't worth the additional hassle and the cost that the contractor would pass on to actually cut the blocks and fit the curve. So what we do is recommend squaring them off using half blocks and side blocks so you create a nice edge. If you have something like a manhole cover, You can a sewer manhole cover. You can see the round thing, just leaving it, squaring it up, and then filling it in with concrete. That makes it a lot easier, minimal block cutting, so you're not dealing with any of the hassles and OSHA requirements around cutting, dust creation, any of those things. Contractor moves a lot quicker because usually it's not hard to place big surface areas. It's when you get to the edges that they really spend a lot of their time, and that's where the money adds up quickly. The other thing we've started to see is installation benefits. So looking at a traditional street versus a street with a P-ACB incorporated into it, you don't have your inlets, there's no ribbon curb, there's the sanitary pipe, but no stormwater assets. They're easily repaired. So if a block were to break, you can take one out, you can put it back in. If you need to get underneath the surface, so you get to the buried infrastructure, you can actually take the whole surface out, set it to the side, dig down, replace everything back in, do your excavate the stone, do your repairs on the buried infrastructure, put the stone back, put the blocks back, and then no one's the wiser that anyone had to go underneath the surface. No patching, nothing like that that's left. We actually had an installation at Ford Motor Company. They put one of our earliest installations. They've been plenty happy with it, but they needed to redesign their parking lot, so they moved it to the backside of their lot. They basically took up a P-ACB installation, picked it up, and moved it to a different location on their lot. So in addition, by not having these stormwater assets, you're saving a fair bit of money. Additionally, circumstantially, we've started to see the asphalt that's adjacent to the P-ACB strip lasting longer, because asphalt does want to expand and contract with changes in temperature. That ultimately results in potholes and cracks, which is really what you're trying to prevent. But the P-ACB, because of the open joints, because it's handling all the water, because it's putting it in a place, it is not, we've seen a lot less cracking, a lot less repair on the adjacent roadway itself, which is really a big plus. So we got a review question here. If you weren't paying attention, I hope you can see the picture behind it. But is it recommended to place the blocks before or after pouring the concrete or asphalt? And Patrick, I see your question. That is a detailed question. I will be sure to actually address that when we get towards the end. Yes, before. A lot of befores. All right. Everybody was paying attention. Okay, excellent. Before it is indeed. That is the recommended installation order of operations, placing the blocks before you pour the adjacent concrete or asphalt. So I'm going to jump into the third part of this. The third learning objective is around stormwater regulations. And this is really a big one. We have stormwater regulations because we as humans have decided to change the environment. We like impermeable surfaces. We like to walk on things. We like to drive on things. We like to them to not be mud. Problem is when we do that, that changes the hydrological properties of the natural environment. So we've created all these regulations to account for the fact that we really like roads and we really like driveways and we like sidewalks and walkways. And so we've put them in place to manage flooding, runoff, and other issues that come along with it. Critically, what we've kind of failed to do is we've created these massive assets, these massive structures. And in reality, one of the better ways to address this solution is where we create the problem. Solve the problem where you create the problem in a distributed fashion. And so we think this is one of those great ways to do that without necessarily having to make the whole of the area actually a permeable pavement. But I like to start with an infiltration demonstration. Oop. So what you can see here is I was trying to mute the sound. My bad. Let's take that down. Start this over. What you can see here, this is a fire truck from the city of Bladensburg, parked on top of a P-ACB system. And what we did was you take the whole fire truck and dumped all of the water out onto the surface itself. And what you can see here is that basically as quickly as we can get the water out of the truck, it is down into the P-ACB system. In total, total was about 550 gallons and about 75 seconds got in there. Really, the water doesn't run with any real distance any which way on the surface. It pretty much falls instantly right into those joints. This is a 78,000 pound fire truck that's sitting on there. And this system, we are proud to report, has actually had no maintenance done over 10 years. So it really is performing like this without any real work and any maintenance work being done to it. So you can see that it takes on a lot of water as it goes, and that's pretty much it. So no maintenance after 10 years. So really, it's quite impressive in terms of its ability to take on water. But we like to compare it to other systems to just kind of help you understand how this is different than any other system that you're used to. And so what we talk about is surface infiltration rate. So this is not the soil infiltration rate, this is the surface infiltration rate. Because of these open joints, we have really high infiltration rates. And so what we did was we hired an engineer to go around the city. This is actually the test for 1,600 that resulted in 1,600 inches an hour was on a system that had been installed in the ground for about a year or two. We picked out, again, porous pavers that had been installed for about a year or two, porous concrete that had been installed for a year or two, and pervious concrete, excuse me, and porous asphalt. And long story short, the difference between a P-ACB system and all the other permeable pavement options was pretty dramatic. They really weren't performing up to the 8 inch per hour requirement that MDE has for something to be considered a permeable pavement. But now that I've told you that, now that I've convinced you that the surface can take water, the other part of the equation is how fast does the soil take on water. Soil infiltration rates, a high soil infiltration rate is around 1 inch an hour. So even though we could get 1,600 inches into that, it wouldn't be very helpful in terms of if the soil couldn't ultimately hold it. And so what we've had to do is we actually come back and we've done a lot of censoring and a lot of information in terms of how it actually performs. And so what we've done is we actually replaced one of our blocks, the one in the gray here, with a water level logger. So as the water falls in, the base kind of fills up and we actually track that. And then as the water exfiltrates from the base and goes into the soil, we actually watch the water level logger fall. This system did have an underdrain in it, but we put a valve on the end, so basically turned it into an overdrain. So as long as there were less than 37 inches in this base, the base was holding water. We did this up in Cudahy, Wisconsin. I don't know what this drawing is on my slide, but sorry. And so there was a rainfall event, and we set up there was a P-ACB system installed in an alleyway. The run-on ratio from this area was a 33-to-1. So that means for every 1 square foot of P-ACB permeable pavement, there was 33 square feet that ran onto it. So for every inch, another way to think of it is for every inch of rainfall that you would see, 33 inches actually went to the base, actually went to the system. The soil infiltration underneath it, the soil was clay. So per USDA standards, that should infiltrate about 0.04 inches an hour. And what you can see here is in red and green, blue. Sorry, I'm really having a colorblind day here. You can see that there was a 2.5, just over a 2 inch rainfall event. So the 2 inches fell pretty quickly within about a 6 to 8 hour period. And then you can see it tapered off. But what you can see here in red is actually the water level logger itself. So immediately as the rain is falling, it goes into the base. It does not overflow. And then very quickly infiltrates back out. In a day and a half, it's actually completely empty again. So comparing that to the initial infiltration rate, so when the base was full and you had the hydrostatic head on top of the water in the reservoir, you're seeing infiltration rates north of 1 inch an hour. Overall, over the whole system, so incorporating this long tail here, you're seeing infiltration rates closer to about 0.4 inches an hour. That's a really dramatic difference. That's the difference between it being permitted and not permitted, even under MDE stormwater guidance. This is the difference between Class D soil and effectively just the tail end, the lower end of a Class B soil. Why is this happening? It's not happening because we found really special clay soil. soil is heterogeneous. It's never really just one type. And the current rules kind of say, no matter what you find, assume it's the worst. When in reality, it should be assume it's the best you find. It follows the pathway of least resistance. It goes through the sand channels, and obviously there's only so much. It's not all sand, but it goes through the more porous soil and gets quickly back into the system. So over a large area, it's able to infiltrate. You're able to use the heterogeneous pathway, the three-dimensional pathways for sand seams, and that actually takes the water on very quickly. We've seen this over and over again, and we're actually doing a study right now. So this study was done in Wisconsin. We're actually in the middle of a study with the University of Maryland in Prince George's County to help kind of reinforce it. But really what we're seeing, overly conservative soil infiltration rates in our stormwater permitting are actually limiting how the stormwater, how we actually allow the stormwater BMPs to perform, and ultimately causes us to either over-design our stormwater assets or improperly rule out things that could be or should be done. So this is the study we are currently doing over in Prince George's County. So this is some early data. Same thing in orange, you have the rainfall numbers, and then in blue you have the water levels per the state, per the county permit, per the stormwater permit. We were expecting to see that we could store 376 cubic feet of water. What we're actually seeing is a number that's about 5 times that in the system. We're seeing soil infiltration rates again that match what we saw up in Wisconsin. As much as I like to think that Maryland is a very special area, unfortunately, our clay soil looks just like Wisconsin's clay soil. And really, that's what we're seeing. Over and over, we've seen the data from these systems show that the soil infiltration rate is significantly elevated versus what we were expecting. Why do we think the regulators did that? It's because the surface itself was starting to fail. So the permeable pavement surface, whether it was pervious concrete or porous asphalt or P-ACB, that was actually limiting the factor. The water couldn't get down into the base quick enough, when in reality, the base was functioning actually quite fine. So decentralized stormwater management, I'll stress that a lot. I think that's really the best way to address this situation. If you're creating a problem, address it at the source. Where is the source of the problem? It's our love affair with hard surfaces and impermeable surfaces. All right, let's turn those into permeable surfaces. And the beauty of using a P-ACB system is you don't need to take the whole roadway and give up your asphalt. You don't have to give up your concrete roadways. You don't have to give up your sidewalks. You just need a little bit of a strip, a little adjacent space, and you can handle significant amounts of run-on. And because it's handling the run-on, you don't need it everywhere. You can put it in in lower trafficked areas so that folks, or you can put it on sidewalks or adjacent to stuff and really address the stormwater challenge where it turns up. Again, there's potential for LEED credits here. So from rainwater management, heat island reduction. So by using a lighter surface, you can protect or restore habitat, because basically you're not creating these artificial green infrastructure structures, stormwater structures adjacent. You're allowing to keep the natural environment natural. There's a really big thing to that. Certainly in tighter site plans, we need engineered structures. We need engineered green infrastructure. But having this option in your toolbox is really important. Just with last performance question here, what is the observed surface infiltration rate of a clean P-ACB system? Is it A, 1.6 inches an hour, B, 16 inches an hour, C, 160 inches an hour, or D, 1600 inches an hour? Let me see if I can figure out how to get these drawings off. Clear. I don't know what's going on here. Okay, there we go. Drawings are gone. All right. I have 2 folks participating. I appreciate you guys for still paying attention. All right, yes, the answer is indeed D, 1600 inches an hour. That is the magic number in terms of how these perform. But you're saying, Aaron, that's great. You installed it. It works like it should. but what about over the life of the project? So this is really where P-ACB begins to shine. We've all worked with homeowners, and we can tell them what the recommended maintenance schedule is, but they aren't going to do it. And this is where P-ACB comes, really works really well. It not only begins with a high infiltration rate, it takes a lot longer to clog. It is possible to clog these systems. The open joints, when they do need to be cleaned, are significantly easier to clean. You don't have to replace the joint material back into it. You don't have to repair the surface. It's really quite easy. From a maintenance perspective, there's no green infrastructure. There's no plants. There's nothing living in them. So the plants stay where they are. The green infrastructure, the softscape stays where it should. And we've documented this with multiple university and governmental studies. And that's where I like to start, is with the abuse test. We did everything we could to clog it. We went down to Central Florida, we dumped some sand, we poured some water in, we baked it. That system is clogged. It does not perform anywhere near 1,600 inches an hour. But performing the recommended maintenance, we were able to bring back 90% of the original infiltration rates. We were back closer to 1,500 inches an hour. That is the maintenance that can be done at any time. That's the only maintenance we recommend. There's only one maintenance thing. It's just suck everything that's in the joints that is in there out, and you're able to restore the performance that you originally had expected when you installed the system. That is absolutely wonderful. It's the best way to do it. The only way to kind of get back to that with any other system is to completely rehab or replace the system with any other permeable pavement system. Now to convince you it's possible to do maintenance, we went through and did a little bit more on the regular standardizing the maintenance guidance. So how should it be maintained? When should it be maintained? How to do it? So we went through a few different strategies to get to that test result you see in the abuse test. So this we actually did slightly before. We went through and evaluated 3 different maintenance strategies using a vacuum truck, compressed air and water, so like an air knife, and then a vac head and combination sewer truck. So this is putting a little bit of pressure water in and then also sucking it back out. As you may have caught from my previous slide, what we did with the abuse test, we recommend that strategy. And so you can see here what a clog system looks like. It is visually clogged. You can see it in the joints. The joints, you could stick a tape measure in, it doesn't go down anywhere. But then after having been done, you can restore nearly the full depth of the joint system. So everything that's in the joints should not be in the joints. So from a maintenance perspective, all these bars are telling you here is the green bars are basically we able to restore just about everything we needed. There were a few other maintenance strategies that do work. We certainly, but the one we recommend is the vac truck combined with the vac head. So pressure washing combined with the vacuum feature. And really, can you do the maintenance effectively? The city of Louisville, what they were able to demonstrate here was that they were able to capture all of the water that they thought they should capture. So the red line and the black line are basically on top of each other, which basically means that they did the right maintenance. They did it when they observed it was clogged, and were able to capture all the water they expected to capture in the system. The next question is, when do you maintain a system like this? Obviously, when it's visually clogged, that's a pretty good sign, but it doesn't necessarily need to be done by visual observation. You can do it based upon sensors. So we did a nice sensor test here. And so as you can see, they clog in a very linear pattern. The water flows on, it drops some debris, and then it proceeds to keep clogging down further and further as the water proves down. Your sensors are able to tell you how much water they can take on, how much water they should be taking on, because obviously you know the effective run-on ratio. And so when that water doesn't come in when it should, then it's time for a maintenance cycle. So I'm just going to show that vac head here so you can see what's underneath it. You can see that the gentleman here, it's connected, that hose is connected to a vac truck. The smaller hose in the middle is for water. So what it's doing is it's shooting down water from these spinning heads. We'll tilt it up in a second, you'll be able to see it. By passing it over this, it basically knocks all the debris loose that's in the joints. And then what you can see effectively is pretty much the joint looks almost empty underneath it. It's really quite amazing. It's quite a simple idea. We kept getting asked this question, so we actually designed this piece of equipment ourselves because we figured it would, everything else that we've seen in terms of maintaining permeable pavements don't work effectively. So you can see there the spinning wands that break up the debris, and then it's sucked back up into the truck, into the vacuum. You can also use the vacuum truck itself directly, like an Elgin Whirlwind or something like it, directly on larger surfaces. So this vac head is for smaller surfaces, for just a few parking stalls. If you have a roadway, you can take the Elgin Whirlwind directly over it. All right. So you can see here, this is actually an example of it done with an Elgin Whirlwind vacuum truck. You can see the vac truck, what it looked like when it was clogged, what it looked like after the first pass, and then after a few more passes, it's fully restored to its full depth. So anything that was in the material, everything that was in there is now gone. So you can see here, this is just, it's an or equal kind of recommendation. You can see it gets as clogged as it gets, first pass, and then first pass does wonders. And then by the 8th pass, we've pretty much sucked everything that was in there out. I will note, because of the open joints, the water does follow the path of least resistance. So even when a system does look clogged, as it did when I went out with Montgomery County DEP, the system they maintain, it was still doing 400 inches an hour. A system that visibly was clogged was 400 inches an hour. After they did the maintenance, they were able to restore 1,000, north of 1,000 inches an hour. They weren't even doing the right maintenance process that we recommended. They were just using an air knife to just knock the debris out, but that was also knocking some of the debris further into the joints themselves. You're asking the other questions here as we come out of winter. What about salt? We don't recommend salt on these systems because ultimately the salt that you put there is going to end up back in the water supply. But we can tell you to do that, doesn't mean what it is. We recommend sealing the blocks. That effectively prevents the salt and corrosion that would occur with the blocks. The edges are chamfered, that avoids some of the catching of the snowplow. And what you can see here is, but they can be effectively plowed without any issue, as you could. So the blocks are pretty good in terms of handling this. Just some other benefits I like to kind of stress here. You never have to replace the joint filler, so you never have to come back at the 1 month mark as you're supposed to with all traditional permeable interlocking pavers, or the 3 month mark. You don't have, there's no joint to fill back in as it settles in. Anything that's in that joint should not be there. We have done north of 4 million square feet, a good chunk of that through the upper Midwest. We've never had any issue with freeze thaw heaving or frost heaving. These systems, there's enough void space in them that the water, as it freezes, the water occupies more of the void space, but it does not effectively compromise the system. With our work down in Florida, we've actually seen a lot of interest in high water levels. So they have sunny day flooding there. This system works effectively in reverse as well as it does going forward. It does not care which way the water is going. It is pretty agnostic to the water. It's used to living with water. It began life as an erosion control system. So by allowing for this, as you get the sunny day flooding, as the water level rises, it passes through all the pores and joints, and then as it subsides, it goes back. If that was a traditional concrete pavement, that would have cracked pretty badly. The long lifetime of concrete, you're looking at 40 years or so. It can pretty much go as long as you need it to. A single person can replace one of these blocks. I regularly pull them out of sites to show folks. I'm happy to go out and meet you at a surface and show you an example system, but it takes about 10 seconds to pull one block out. If you needed to put the block back in, you just drop it back in. Again, it's the right tool. We have a nice slab grabber that does that. And the beauty of this system is we really don't recommend it for the full pavement. It's when we start to design a system, we usually look at somewhere between 10 and 15% of the pavement surface, turning it into something like this. But what is great is it makes traditional pavement much more resilient. So there we go. So what is the recommended method for cleaning of open joints in a P-ACB system? This is my last question here. I just gave it to you. Is it A, use a vacuum truck? Is it B, pressure wash? Is it C, give up and replace the blocks? Give you all a chance, and then I'm gonna a couple of housekeeping items, and then yeah, somebody's paid attention to when I press the button. But before I get that usual question, I will be providing a copy of these slides. There is a recording that will be posted to AIAPV. Nothing in here is proprietary or secret. Feel free to use this information. Feel free to reach out to us. Always happy to talk. Yes, for everybody who has been answering, it is indeed the vac truck. You can also use the vac head as well. Just in summary here, it lowers the total cost of ownership over traditional permeable hard surfaces. And I have some numbers I'll show you after this. It simplifies the maintenance. Even if you don't do the maintenance, it works really well. We have a no maintenance warranty for permeable pavement for any system that we install that is purchased through Ernest Maier, which is quite impressive. I don't think there's anybody else who would warranty their permeable pavement. It's really a strong stormwater management tool in your toolbox. It shouldn't be the only thing in your toolbox. Microbial retentions, swales, all those things are really important, but this is really a great tool to have because as soon as you need to put parking, as soon as you need a roadway, this is a way to not create the stormwater challenges that you have. And we've actually seen a lot of places take the water that falls on a roof and actually run their downspouts straight into the base and able to handle the water that way. So it's a great or equal alternative. And it's pretty much the only alternative you could use in high traffic right away or slope situations. So more reading and reference, this is really just for you when I press the slides around. If you're not thinking about a P-ACB system, you should be. It paves, it drains, and it also stores your water. And it's not something you're going out on a limb with. We've done this, we've installed these systems for 15 years now. We've also done north of 4 to 5 million square feet nationally. So this is really not a system that is new or novel. We really wish other people would copy us and use some open joints, but they are reticent to do just that. Just some other resources that you can have. We have an infiltration calculator. So if you're the kind of person who likes to say, will it work? We built a calculator just for you. It's a nice, fun tool. You can select, you put in the zip code that you're working on a project. It'll give you the actual rainfall from the NOAA Atlas 10. The NOAA Atlas will tell you what the 10-year event, what the 100-year event, what the 1,000-year event looks like. And you can see whether or not pave drain would be able to handle that. This is my contact information. So if you're interested in reaching out to me, I am always happy to talk about stormwater management. That is, I spent 5 years doing innovation at the Water Research Foundation, helping utilities across the country innovate. I was really excited by this product. If you have other questions about any product Ernest Maier offers, I'm happy to be your front door. I'm not the most knowledgeable person because there's a lot of really smart people here, but if you need samples or anything like that, from a design, from a performance perspective, we're more than happy to talk to you and address some of those things. I did mention this really quickly, the manufacturer warranty. This is one of those nice things that you won't get anywhere else that customers love having. We have two types of warranties. So if you're doing the recommended maintenance process, which we recommend just about every 2 years, or as needed, you will be able to see 500 inches an hour. Where did that value come from? There is no other permeable pavement system on the market installed that would even certify that says they will hit 500 inches an hour. That's perfect conditions for them. We will warranty with maintenance to 500 inches an hour for 3 years. And we'll actually warranty over 6 years. Even if you do no maintenance, it'll still do over 8 inches an hour, which is great if you're trying to hand over to a homeowner looking at a driveway. If they really need a challenge to handle that stormwater, this is a great solution for that. I'm happy to give you the details in the fine print. And this is the last slide I've got here. We did a little bit on total cost. So you're trying to think, yeah, this system might be a little bit more expensive. You can see those blue bars. We're comparing permeable pavement systems to each other. You can see what pave drain looks like versus other traditional systems. You're paying a little bit more than any other system. But what you pay for initially, you do not pay for in capital and uptake, in maintenance, operational and maintenance costs. It's a really good system. And then critically at 10 years, porous asphalt, pervious concrete, that's all supposed to be repaired, like full on rehabbed as per the manufacturer's guidance. So effectively now you're rebuilding the whole system at that 10-year mark. When you're comparing that to pave drain, it really competes on a price basis with on a price per square foot basis of like conventional asphalt or conventional concrete, where you do have to put in stormwater assets with it. So that's my last thing. I'll leave that up there. I'm happy to address questions. So if folks have some, I'm going to see what I got a few in here. Patrick asked the first question here: what are the requirements for the base and subgrade design? So it depends on the jurisdiction you are operating in as to what they would allow. We have seen that these systems effectively work in all types of soils, A through D. We are in the process of doing the study with the University of Maryland to actually push back on the MDE guidance manual, as well as on the county permitting stuff. This particular job in Comer Manor, I actually have a slide there. We did the soil testing after we dug everything out. It is clay soil. It is Class D soil by all definitions. But as you can see, it was performing in a soil class significantly above what should be expected. So we are working with the University of Maryland to help create to recognize how the systems are actually performing. We've actually been able to get almost a near blanket exemption from the Wisconsin's DNR, who is equally as tough as Maryland's Department of the Environment, in terms of allowing the system anywhere. In terms of the base design, is there any other requirements? We recommend bedding it on 57s for 4 to 6 inches. Anything deeper than that, we recommend number 2 stone. We have done systems as deep as about 10 feet. Obviously, you get 10 feet of space to store water at 30 to 40% void space. So there's a lot of volume to store water. Obviously, that is a tough way to attack the issue. It is approved by MDE as traditional permeable pavement, so you can use this in lieu of traditional permeable pavement. Unfortunately, one of the challenges when you do it that way is you have to follow the guidance of traditional interlocking concrete paver. But what you do gain is you still gain in terms of maintenance and performance. Patrick, if there's other questions, I'm more than happy to address them that you.
Yeah, so if we were to do something larger than either intersection or a crosswalk or something, I've seen if we did an entire parking lot with this product, you've mentioned some jurisdictional guidelines from MDE and whatnot, but and DNR, but what about in this area, MDOT and VDOT, your Department of Transportations that have jurisdiction over what a roadway condition could be used for? Is there stuff that you already have pre-approved by those authorities that we could simply say, take this detail from Ernest Maier, and this is the product we want to use at this depth, and it'll be, approved? Or do you anticipate us getting pushback on your product from a jurisdiction who typically wants to see, 2 lifts of asphalt 4 inches thick at 57 stone and compacted subgrade, et cetera?
So we have done work with county DOTs. They have not given us a blanket approval. So we have done work with Montgomery County's DOT. That work was actually done in 2009 in Sligo Creek Hills, and we've done work in, I think it's Carroll County is what I want to say. It's just north of Baltimore. I'm blowing my geography here. And we did a whole roadway curb to curb with them. So we've done it that way, and we've been able to do it on a case-by-case basis. We're working up to the point of being able to come back and get full approval. We've worked with, we have state level approval like in Indiana, Florida, Ohio. So we've gotten full state level approval, and now we're just coming back and meeting the jurisdictions where they are. The county, Montgomery County, I will tell you that our person who actually installed it has been reconnecting. Has been reconnecting with us, and they're like, look, the system works. Like we did everything that was one of our first installs, and I can tell you how many things we've done wrong there. And the system is still performing. And Sligo Creek Hills, if you knew anything about that site, they were constantly getting called at the DOT about run-on, about cars being flooded, about turning into a river road. And since they put that in 10 years ago, they have had minimal complaints. That's what motivates them. And so I can certainly pass along my contact in the Montgomery County DOT. He is a big champion of this. They are actually now coming back to this and looking at this as a solution to address some of their roadway issues, because between the two curbs, there's really not a lot they can do from a stormwater perspective outside of storm drains. And they want to do better. And so a system that can handle heavy traffic like this works wonders. And we've done, I would say, of the 4 million square feet, probably a couple 100,000 have been in roadways. Obviously, we try to avoid, if the road's going like above 35 miles an hour, this is not traditional roadway materials, but we try to do oh my God, I'm like having a hard time here. The shoulders, we try to do the shoulders so where there's less traffic. So it's certainly something they can drive on, but because it can handle such run-on ratios, we don't want it in the drive lanes. It's just easier to handle it that way. The other thing, when we talk to DOTs, they're generally pretty receptive. Usually the biggest point we talk to them about is the difference between an open graded aggregate and a closed graded and a dense graded aggregate. They're so used to doing dense graded aggregates underneath all of their roadways. So this is where there's no pores or void space for the water. So when the water gets in there and freezes, it cracks every roadway. And every DOT can tell you that, every DOT that has to deal with a freeze thaw will tell you that that is their biggest problem. And so by using an open graded aggregate, there's a space for the water to freeze. There's space for the water to do what it normally does. And once it really gets into the base, it generally is a little bit warmer down there. The frost line is generally below the frost line. And these systems work. So we're happy to talk with you. And if you have a specific project in mind, and we've done work in right-of-ways, and we've had no issues. That Comer Manor roadway has actually been in there for a year, and we've had no complaints. And it's the only reason it's only been in a year is because that's when we installed it. It'll go another 39 years without any issue. So Patrick, if you have a specific one, I'll reach out to you and we can chat if there's a specific project you had in mind.
All right, thank you very much.
Sligo Creek Hills, yep, we'd love it. How are site plan reviewers in different municipal viewing as far as on-site stormwater calcs? So Tyler, how long do we want to talk about how people review stormwater permits? So officially, if you talk at the state level, the state has issued a guidance manual, it's a guidance, not rules. So the state has effectively passed it down to the counties. You talk to anyone at the county level, they will tell you the state has issued rules and they're just enforcing them. And so generally what we've seen though is from a municipality, so if you go down to the town or city level, they recognize what the actual problem is here, and they have pushed back very effectively on the counties. So a lot of our installs have come because town commissioners or mayors are like, I know my city is flooding. This limits our economic activity on whatever street. People don't want to live there. And they've effectively been able to push back on that. This study that we're doing with the University of Maryland is part of a broader effort to push back on a state level that says the conservativeness of the calculations, that you've put conservative and fudge factors and engineering guidance in that's not actually matching what's really happening in these systems. And so that's where the data has come back. And so we have probably installed about a dozen of these underground sensors to verifiably demonstrate that this works like it should. Unfortunately, a lot of times they might just come back and just say, no, it's just, I can only give you credit for 12 inches at this rate. And so unfortunately, it's been a little bit tough to push back, but if they're willing to talk, we have data that pushes back and effectively kind of addresses the situation. And we're working on getting more of a permitted exemption because what we're seeing is really the surface is failing of our peer systems, and we're having to answer for their sins in the rules, unfortunately. I wish there was a better answer. I wish the stormwater folks, this has been one of my pet peeves. I'm sorry for going off on a tangent here, but unfortunately, yeah, with our stormwater, the stormwater assets we're putting in place, the stormwater plans aren't really working as well as they should. If you talk to if you sit in on any Chesapeake Bay meeting, they're like, yeah, we did everything we thought we could, and Bay Health is still going down. And it's going down because there's runoff, there's nutrients, those kind of things in our stormwater. And being able to address this in a decentralized fashion exactly at the real source of the problem and address it correctly would be the best way to do that. And so we've seen really good response from engineers who are very cognizant of that failing, but some that are just bureaucrats. Unfortunately, they're reading the rules, or they're reading the guidance manual as rules, and they're sticking to their guns like that. And so in a situation like that, we've been able to get back. We've been able to get a little bit positive movement, but not as much as we would hope. Even the city of Rockville, they're ripping out porous asphalt and pervious concrete and putting this back in its place. They've all learned that everything else is not working over the lifetime of the project, over the lifetime of the site, and this system is moving forward. So sorry for that little tangent there. It's a frustration, personal frustration of mine, but I'm happy to sit down. I'm happy to throw around some of my my years of degrees and knowledge to help address the challenge to build something correct that'll last. So I'll go back to my. I don't know if there's any other questions. This is my contact information. I know I kind of ran 3 minutes over here. There I am. This is me. We have systems all throughout the county, all throughout the area. So if you do want to take a tour, you want me to pull out a block, you can see how the system works. I have samples and things like that. Always happy to do that. Really, the critical thing for you guys as architects to take away is here's another tool in your toolbox. The right-of-ways, the drive aisles, turn loops, all of that can be handled with permeable pavement now. And then you can also create a system that requires significantly less maintenance so that the owner is not doing any of the challenges that they're not experiencing any of the challenges that basically that's the whole reason we have stormwater regulations is to address the challenges. And this is the best way to handle it. With that, I will stop talking. If you have any other questions, feel free to reach out. I will look forward to seeing many of you at AIAPV events around. Hopefully we're able to, we're looking at sponsoring throw us under the bus here, Sue and Pam, but sponsoring the golf tournament. So folks are there. Ernest Maier's, I guess I could throw myself under the bus. Yeah, we're certainly looking at getting that event back up this year. So if not
in
there,
August, so people can be looking at their calendars in August. As of right now, we are targeting August 8th, weather permitting.
So, all right. Well, thank you all. I did get the one LACES request. If there's anybody else at a LACES request, landscape architect, I'm more than happy to make sure that you get the credit for listening to me talk, and hopefully you learned something today. And please do fill out the course eval if you have the opportunity to. I will chat that in again. And that is it for me. Thank you all. Have a wonderful day. I appreciate everyone sticking with me. Bye.
Thanks, Aaron.
Thank you.